Hello, everyone. I hope you are doing fine and happy new year. Today, I want to talk about the functions. This is a part of calculus that we'll be talking about. But before we go into deep calculus, we want to see what a function is. So we have different situations, okay? And we talk about functions because one quantity depends on another. Look at the area of a circle, okay? We say that the area of a circle is given by area equals to pi times the radius squared. So area depends on the value of the radius. Whatever value you select for the radius, it will give us a value of A. So in that case, A depends on R, okay? So A is a function of R. On my left here, I have a table showing the world population in millions since 1900. You can see in 1900, the world population was 1.65 billion people, okay, or 165 million people. Then in 1910, that's 10 years after, okay, the population went to 1.75. You can see what happened in 1920, 1.86. In the 1930s, we had 2.07 billion people. And in 2010, the population was 6.87, billions. So the population is going up with time, and therefore we say that the population is a function of time. Okay, so we have different scenarios. You have been talking about the volume of a sphere is given by V equals to 4/3 of pi times the radius cubed. Okay, so you select values for the radius R, and then you get the volume of V. So in this case, the volume depends on the radius. So volume is a function of the radius. And that's what we want to discuss in this class, okay? What is a function, okay? What is a function? So we say that a function is a rule, okay? A function is a rule that assigns, a function is a rule that assigns to each element x in a set D exactly one element, okay, called f of x in a set E. So we will talk about this in terms of set notation. You have one set, which is D, and then the other set, which is E. So a function will assign, okay, each element of D exactly one element, f of x in E. Okay, we'll talk about that more, the definition, it will be discussed. So we usually consider a function for which the set D, okay, the set here D and the E are sets of real numbers, okay? Real numbers are positive or negative rational numbers. The real numbers cover both positive and negative. They cover the integers, they cover the fractions, and therefore that set, we call it a set of rational numbers. Okay, so we are going to deal with the real numbers. We want to see if you have an element in D, okay, and then a function acts on it and it gives us an element E, okay, do we have a function or we not have a function? Because there are two situations. We'll be discussing this. So the set D is called the domain of the function, okay? The number f of x is the value of f at x and is read as f of x. You can see f of x, this is how you read, okay? You don't read f times, no, it is f of x. Okay, this is just introduction. The range, you can see range of f, the range of the function is the set of all possible values of f of x as x values throughout the domain, okay? So if you look at the x values in the domain, what will be the range of the x values in the set E, okay? Yeah, so we'll still understand more what the range is. A symbol that represents an arbitrary number in the domain of a function f is called an independent variable. An independent variable is that symbol, okay, which represents an arbitrary number in the domain of a function f. Okay, so a symbol that represents a number in the range of f is called a dependent variable. Okay, so let's look at this. Let's examine this. You have the area A of a circle, and it is given by the formula area is equal to pi times the radius squared. Okay, so area depends on the value you assign to the radius. Okay, so r is the independent variable and the a is the dependent variable. So we are introducing functions here, and what we are trying to understand is what is an independent variable and what is the dependent variable. Okay, still I have this example. The volume of a sphere is given by 4/3 pi r cubed. So r is the independent variable and the v is the dependent variable. We'll be selecting, we'll be selecting symbols to represent functions because you cannot keep writing the same. If you write it in terms of words, it's going to take a lot of time and space. So I'm talking about the radius. So I select r to be the radius, and then I select v to represent the volume. Okay, so how do we think about functions? I want you to think of a function as a machine. You have a machine, you input, and then you get an output. Okay, so if I input x right here, I have x, I'm inputting x, and then I'm getting out f of x. So f is the machine here. The other way of thinking about functions is to think about this in terms of sets. Set D, this set D, has elements x, a, and then the star element here. So it is acted on by a function, okay? So the function changes the value of the elements in set D to set E, and the values will be f of x because we get these values in set E by computing using a rule. It can be a formula, like you can see the area is given by pi r squared. So if you have r is equal to 1, the area in set E will be pi. If you have r is equal to 2, the area in E will be 4 pi, Yeah, so that's the rule. So we have the domain and the range. The domain is a set of the independent variable, and then the range is a set of the dependent variable. Okay, functions can be visualized by plotting their graphs. Okay, so if you want to see what the function is, you have to plot the graph of the function, okay, with the domain and then the range. So what is a graph? A graph is simply a plot of pairs of order. It is a set of ordered pairs. Okay, you plot a set of ordered pairs, x and f of x. In sets we use this symbol. We use these two. We use the parentheses. No, we don't use the parentheses, but use the curly brackets. Okay, this does not work. Let me see what will work here. I think I can use, okay. So this, if I have two, braces which form a curly bracket, this will be a set. And now I'm having a set. What I want to do is to plot a set of ordered pairs, x and f of x, such that x is coming from the domain D. Okay, so if we plot such a graph, then we'll be able to visualize a function. Okay. The graph of y is equal to f of x, the graph of this, y is equal to f of x, okay, gives a useful picture of the behavior of the function. This graph also allows us to picture the domain of f on the x-axis and its range on the y-axis, okay? So here I have a few examples, but these are just examples, You have a function which is this plot. It gives this curve. And we are looking at this for the domain from x1 up to some value x. The values of the function, you can see this is its lowest value and this is its highest value, okay? So in terms of range and domain, you can see that we are considering x values from x1 up to some x. And then the range starts from the lowest value right here. So it is this, the lowest value. And then the highest value is this value here, the peak, that's the highest value. The rest of the values we just keep repeating. So the range is from this value here, okay, to some value right here. And the domain is from x1 up to some x. So that's how you can visualize the function. For example, if let me look at this. I have used this example. Okay, let me try to magnify and see what I'm talking about here. So look at this function. Okay, this is a function defined for the domain. The domain are the x values. We start with the x is equal to 0. And then we go in steps of 1, 1, 2, 3, 4, 5, 6, 7. So it starts from 0 up to 7. That's the domain. And then we compute the values of the function. So the graph will be the plot of the ordered pairs. 0 has 1, okay? And when x is equal to 1, the value of f of x on the vertical axis is equal to 3. When x is equal to 2, the value of f of x on the vertical axis is equal to 4. Okay, you can see this is 1, this is 2, 3, and 4. So this point here is a plot of a pair which is 2 and 4. Okay, so you can see when x is equal to 3, this comes back to 3. When x is equal to 4, it comes back here to about 1. And this value here, we cannot read directly, okay? But when x is equal to about, this is 4, 5, 6, okay? About around 6, this value is about -2, okay? Yeah, and then the function, because I don't have the function, but you can see exactly here what we are trying to say, that for this function, you have, I try to, okay. So you have the domain of the function is a set of the x values, and you can see this function starts with x is equal to 0, and it goes all the way up to x is equal to I think 7. Yeah, from the x is equal to 1 up to, yeah, x is equal to, yeah, you have here, but we have been counting, so we don't need to struggle so much with that. Okay, the domain, if they ask you about the domain, this is the domain. Domain is, this includes a 0. So we use a brace. So this is 0, and it goes up to 1, 2, 3, 4, 5, 6, 7. So the domain is from 0 to 7. Okay. And then the range, this is the set of the y values. Okay. Is we pick the lowest value. Okay. The lowest value here is, the lowest y value is -2. It is about -2. So it includes -2 up to, okay, 4. And then what we are seeing, the plot, this plot you are seeing here, okay, is a plot of x's and y's, okay, such that x is from 0 to 7, and y ranges from -2 up to +4. Okay, so we'll understand this more in the next part. But that is a brief introduction I wanted to give you about functions.